Hello guys, and welcome back to another game development tutorial. It has been some time, 2 weeks, and as you can see, I might be quitting YouTube or this channel a little bit soon, so I'm not as motivated now, but that might change in the future, so hopefully that changes. But hopefully I will finish the series. Okay, so first episode we will be changing some movement, and we will also hopefully be getting into some ground spikes. So, as you can see right now, the player sometimes bounces up, he gets stuck on things, like that. So today, we will hopefully be changing that up. Okay, so, let's actually begin with the main player movement. So before anything, in the rigid body component, in the rigid body 2D, for interpolate, I will set that back to none. And this is because I am going to change the movement style, and the movement style that I'm going for, if this interpolate is on, it will be very weird. The gravity will be all funky. Okay, here we go. Okay, that is where we take our place of our jumping. Okay, and here is our problem right here with this line of code. Okay, so we will not need any new variables, but one thing that I will do is I will delete this whole fixed update function. So there we go, gone, deleted. Instead, I will write this new function in the update function. So, what I'll say, and why I'm writing it in the update function is because this is not involved with physics. It's just making the player go in one direction or the other. It's not adding force to the player at all. So, what we can say, transform with a lowercase t, dot translate, then in parentheses we need our translation as it's called, but in simpler terms we need our x-axis, so our left and right axis. So, this will be our move speed, because we want to control how fast we move our player, multiplied by move input, and we want to multiply it by time dot delta time, and we are not multiplying by a fixed dot delta time because the player should not do that weird move anymore once we've done this way of moving our player. So then I will say comma. For our y-axis we will say 0. For the z-axis we will say 0. Because we do not want to move the player on the y or the z-axis when we are moving. Okay. And just like that, if you go back into Unity, make sure to save your script with Control S. Let's go back into Unity. And by the way, if you're on a Mac, when I say Control, I mean Command if you're on a Mac. So to know that. Okay, first of all, before we press play, we still have some things to tweak. So first of all, I will check my move speed. Because now we're doing a different move method. So I will set that actually to 25. And I think I'm just going to check off double jumping. I've never really been a big fan of double jumping, but if you like it, then you check that back on. Our player moves, pretty nice. But then, if you see, if he gets against a wall, he will do this weird jitter thing and sometimes even pass through the wall. So this is not as easy as last time. It's not a single setting that we have to turn on, but we have to write this through script, and it's a bit harder. Okay. So first of all, if you're wondering why we turn this interpolate off, if I just turn that on, if I just move, things will start to get weird in later versions. And now I'm in 2019 version. You guys are probably in around 2020 version. And if you keep that on, the gravity will be weird if you jump and move at the same time. So we don't want that. So that's why we check interpolate off. Okay. I think I'm going to turn my move speed down to 22. then let's work on our player not jittering through the walls. Okay, so this is pretty much the same thing as the is grounded. So this will use the same function. So I'm gonna open up my player movement script, and at the top we need some new variables. So what I will do, I will go under our jumping header, that line that ends on line 23. Then I'll make some space with enter. Type in header. Then in quotation marks, I'll type in what the header wants to say, and I'll call this movement fix, or just something like that. Then for here, I will write public transform, and I will call this side check left, and I will make another public transform. I will call this side check right. Okay, now we need two more variables. I'll say public float, and I'll call this side check area. And then I'll make one more variable. I'll make a public layer, and I'll call this collidable. Okay, so those are all of the rules that we will be using. So now we actually want to use them. Actually, sorry about that, I lied. Oh no. We need two more variables. We need a private bool called canMoveLeft, and a private bool variable called canMoveRight. Okay, great. So now, just like how I did, this is grounded. We want to draw a circle by the player's side. Then if that circle collides with anything on this collidable layer, the player will stop moving to that side without the jitter. So, what I'll say, just like how I said is grounded, I'll set canMoveLeft equal to physics2d dot overlap circle, since this is a 2D game. Then for our position, we want to make the circle. I will make that position side check left dot position. Then for the area that I want to check, I will make this side check area. Then for the layer mask, I will make that the collidable layer. And there we go. Now we want to do the same thing for the canMoveRight. So I will copy this entire line, Control C. I'll paste it right below. Now we just have to change some of the variable names. So instead of canMoveLeft, I'll say canMoveRight is equal to physics2d dot overlap circle side check right dot position. Then all the rest of the variables shall remain the same. Okay, so now if we go back inside of Unity. Okay, great, I am filming. I just wanted to make sure of that. And now we can set this side check area to something like 0.1 for starters. Then we want to set the collidable layer to just ground for now. And then for our side check left and our side check right, I'll go under our player, and just like how I did the ground check, I will right click on the player, create an empty object, and I will just create an object that's called right check, and on the X, I will set this X position to 0.5, and then I will duplicate that, so with Control D, I'll rename this to left check, and for the X-axis, I'll position it on negative 0.5. So exactly the other side. Okay, now we can almost test this. Let's go to our player, game object. Then for our side check left, I can drag in my left check. Then for our side check right, I can drag in my right check. And if you do not like dragging things into slots, I personally do. I think it's a bit satisfying. But you can click on this little circle right next to that, and it will give you all of the game objects in the scene. And you can just select the game object that you want to insert into this slot. Okay, so now to test this, we can click on these three dots. Make sure that you have your player selected. Click on these three dots, and you want to go to debug mode. So this is where we can see all of our hidden variables. So as you can see, we have our can move left and can move right. Okay, so when I collide with something, they should check. Yep, so as you could see before I glitched through the wall, if I go right there, yep, our can move left is now checked. And if we go against the right wall, can move right is now checked. Okay, so let's go back into normal mode by clicking on these three dots and selecting normal. And I'll go back into our script. So since these check every time we collide with something, we might want to rename these variables. So for the private bool can move right, I will rename this to. So I will select the variable and press Control RR to rename, so R twice. Then I will just type in can't move left, and I'll press apply to change all of the variables to that name. So now it says can't move left, and I'll do the same thing with this can move right variable. I'll select the variable, press Control RR, this time say can't move right, and press apply, and there we go. Okay, so now we actually want to stop our movement when can't move left is equal to true, or can't move right is equal to true. So yet again, we are going to have to rewrite this bit of code. So I will delete that line, and then I will, down here, I'll make a new function. So I'll say void check controls. There we go. Finish that function off. And then we'll scroll back up into our update function, and right under can't move right, I'll just call this function, so I will say check controls. And there we go. Okay. So then in this function, I'll say if input.getKey, then in parentheses I want to say key code dot, and for me that is left arrow, or, so in case you do not know, to write or in programming you can't write OR, you have to do these two lines. So right under your backspace button, it should be there. Okay, then I'll say or input.getKey keycode.a. And why we are saying get key instead of get key down is get key down just detects the tap of the key, but get key detects if you hold the key down. Okay, so then we want to say if input.getKey, all that stuff. Then inside of this if statement, we also want to check if can't move left is equal to false. And if all these conditions are met, then we want to move the player left. So I'll say transform dot translate. Then in parentheses, I want to move left, so I'll say negative move speed multiplied by time dot delta time. Then I do not want to move the player up, so I'll say 0. And I do not want to move the player on the z-axis, which I cannot really describe it because this is a 2D scene. So I just won't, because I do not want to get that far. Okay. So now, what we want to do is we want to do the same thing with the right arrow. So I will just copy this whole if statement, Control C, then Control V right under that. And I'll say if input.getKey keycode dot right arrow or input.getKey keycode dot D. And I'll say if can't move right is equal to false, then I'll move it right, so I'll just be normal move speed and not negative move speed. And there we go. There is our function. So let's go back inside of Unity. And in the description, I will have a Google Doc with all of the scripts that I'm using in this video. So you can go there, and if you have an error, you can just look at my script or even copy and paste my script. So you know what to do next time, or so the error just stops from going away. And if it doesn't, then that something is either wrong with the version that you're on or Visual Studio. Because these scripts are right from this video. So, okay. Let's save our script with Control S. And now, let's test. Okay. So, let's press play. Now, I should no longer be able to glitch through walls. Yep, there we go. I cannot walk through walls. And I also, if you notice, I do not get stuck to platforms. So that's a pretty nice all-in-one. Okay. So since we do not have that much time left, I will just go over Spike really quick. Because next time we will be using more spikes. We will also be making an enemy. So that will be kind of fun. An AI that will just shoot the player. Okay, so if you are in Unity 2020 or above, there's a bit of a different way to do this. So if you are in Unity version 2020 or above, I will call you Group A, and if you are on my version or below, I'll call you Group B. So Group A, to create your sprite, you will right-click in your project, go under 2D Object, hover over Sprite, and you want to select a isometric diamond. And then what you want to do is you want to position your diamond and place it into the ground so it just looks like a normal triangle. And that's pretty much how you will make your spike. But if Group A, if you go over to the object, select Sprite, and if you have a triangle, please use that. Okay, and now Group B. What you want to do, let's go under your sprites folder, and we've already made a triangle, so I'll drag that into our scene. And there it is, there's our triangle. Okay, I will scale this up, so I'll set the X and Y to 2. Y, because, okay. There we go, there's our spike. You can scale it how you want, I think. I like that right there. And you can also change the color to fit this part of the ground right there. So I'll just select this eyedropper tool and do that. And there we go. Now it is the exact same color as the ground. That was pretty nice. Okay, so now what I'll do, I'll rename this triangle to Spike. And then I will give this the ground tag, so the player can collide with this spike. Then what I'll do, I want to tag this spike so the player knows when it hits the spike. So, for the tag, I'll go under this drop down where it says untagged. I'll press add tag. Then I want to add a tag, so I'll press this little plus sign. Then I will name the tag danger, because we will probably use this tag more than once. Then I'll go under the spike and select the danger tag. The last thing that I'll do to this spike is I want to add a collider to it so the player can actually collide with this spike. So I will select add component, and the component that I want to add is called a polygon collider 2D. And immediately you should notice that there is a green outline to this spike. and that is just where the collider is placed. Okay, so now the last thing they want to do is we want to drag this spike into our assets folder so it becomes a prefab. So now we can just drag it and drop it more easily. Okay. So now I'm just gonna position that spike around right there. Maybe move it down a little bit. Okay. So now, and last thing you have to know about prefabs, this is really helpful. If you make a change to your prefab that is in the scene, it will not affect the actual prefab. So as you can see, I sort of scaled it. The scale for the X is 1.5, but if you go back into this spike, the scale is still 1.4. So how you can apply it quickly, besides doing manually changing it, select your spike prefab that is in the scene, go to overrides and press apply all, and there we go. Okay, so now let's actually get the player to collide with the spike and then die. So if I press play right now, the player will actually go up and around the spike. He'll also do the glitchy thing. That should not actually be a problem, because when the player hits a spike, it should just give it knockback to the player. So if the player hits a spike, it should go back there. So it should not do that glitchy thing once it gets knocked back. Okay, so now what we will do is we will add a new script to our player. So I'll press add component, and the script that I want to add will be called player controller. I'll press new script and create an add, or press enter if you're just lazy and you want to do it quick. Okay, then I will just move the script up, so you can just drag it, or you can right click, press move up on it. Those are the two options. Okay, then we can drag this script into our scripts folder. Then we can double click on the script to open it up in Visual Studio. Okay, so we will want to keep both these update and the start method. But we will need some variables. Two of them actually, just for now. We will need a public float called health, so this will just be a player's health. Then we will need a private float called current health. And we will add more variables soon. We will add like a death effect, so when the player dies, he'll just maybe like explode or something in little pieces. Okay, so in the start method, we will say current health is equal to health, because we do not want the player to die immediately, because if we do not set a variable value, it will automatically be set to 0, and if the player has 0 health, then he will die. We don't want that. Okay, so now we will want to write two functions. So we can write void take damage. Then in these parentheses, we want to add a parameter. So a parameter is, whenever we call this function, we have to write the parameter in the curly brackets. So if I just type out the function, then we have to write a value into those two parentheses. So the parameter that I want to include is type float, and the name is just AMT for amount. Then I'll finish that function normally. Then in these curly brackets, I'll say current health minus equals AMT. So that just says that the current health will be minus by the amount of damage that is placed into those parentheses. And we want one more function, void death. That will not have any parameters, and for now, that will just destroy. Then in parentheses, what we want to destroy, the thing that we want to destroy is the actual game object that the script is attached to. So we'll just write game object with a non-capital G. And there we go. Now, if we say, in the update function, if current health is less than or equal to 0, because we have to check if this player has died. And if it has, we will call the death method. And there we go. The script will still not work, because the player still has no way of taking damage, because we have not called the take damage function. So, in order to detect if a player has collided with an object, we will say void on collision enter 2D. So this function just allows you to detect if the object has collided with another object. So we want to detect if we collide with the specific object with a spike tag on it. So how we can say that, we can say if collision.collider.tag then equal to then the tag that we have attached to spike. So for me, that is the spike with a capital S tag. And there we go. We finish off that if statement. Then in here, we can tell it what to do when we collide with that spike. In there, we can just write take damage by 1 amount. So I just wrote 1 in those curly brackets, parentheses. And also make sure that it says void on collision enter 2D. This is a 2D game, not a 3D one. Then we can test this by going into Unity, and the player will still not have knockback, so he should go up and around the spike. That's fine. So before we test, we want to set the player health to 3, and the player can control the script. Then I will press play. And if we collide with the spike 3 times, 1, 2, 3. Let's make sure that I added the spike tag. The danger tag, that's right. Okay, so why I did not take any damage is because the spike actually has this danger tag attached to it. So, in the script, we do not want to write this object name in here. We want to write the tag. That is our danger tag. And there we go. Now it should work. If we just press play. Now if we collide with the spike 3 times, so I collide, and there we go. And why it just did it immediately is because it does not have knockback, and it was jittering back and forth onto the spike. So when we get knocked back, all those issues will be fixed. Okay, and that is about it for this episode. I hope you have enjoyed, and I will see you in the next one, where we will add some player death, post-processing, and knockback. So that should be pretty fun. Bye guys.